I'm doing a class, my friend. Go. The tablet. Don't you think go? Go back. Can't go and tell her come to a class. Sit down. Not for you. But, I can't yet. I can't do classes. Go. Yeah, let me use.
Good evening, everybody. I hope you can hear me loud and clear. Good evening, everybody. Can you hear me loud and clear? Good evening, everybody. Can you hear me?
Yes, we can.
All right.
Good evening.
Good evening. Can you see the screen I'm sharing with you?
Yes, we can.
Okay. Not too many students are here at this time. What is happening? Okay. All right. So we are about to start the class. There are only 10 students here. You can reach out to others to join. All right. Now, when you observe how far we have come, you will notice from the slide I'm sharing with you that we have done in recent days chapter 20, which is transaction management. And last week, we started looking at part 6, which has to do with chapter 22 and 23 and 24. But I'm using the word screen summarized notes to teach these chapters. But you are expected to go and read these chapters, particularly chapter 22 and chapter 24. So we'll continue with the material we were using the other day to complete possibly this segment, part 6, today. When we meet next week, we would quickly handle business intelligence that has to do with data warehousing concepts, and then data warehousing design, data online analytical processing. We could do that also in 2 meetings. Then we'll come back to handle our query optimization and query processing techniques, which is chapter 21. So that's the way we are going. I believe we are covering a lot of grounds and learning new things. Okay. Before I move on from here, as usual, let me first of all welcome all of you back from the elections. The other time I said I want to see everybody back in good health, and I'm happy that none of you have been lynched because you comported yourselves. But I'm still probably thinking that some students are not here right now, and I'm apprehensive. Probably they've joined the demonstrators at the East office. So if you know any of you who has joined the demonstrator at East office, call the person to join the class. And that one will be taken care of itself. So you are all mostly welcome back to class. Okay, that being said, maybe whichever you're feeling, whether your preferred candidate won or lost, I want you to compose yourselves, and then we continue with the class. Life is like that. When two people compete or people compete, only one will win. So if your preferred candidate won, don't be too happy that the lecture will be having, you will not pay attention. If it happens that your preferred candidate lost, to compose yourself. Next time, next round will come, and your candidate will go. So everybody should bring his or her mind here to class so that we can continue smoothly with our class. Okay, I will pause here for a moment, as I always do. Should you have any comment or something you want to share, or a question to ask, or something to clarify, why not? After that, then we would continue with our class. Is there anybody having to seek any clarification? Okay. Isaac.
Prof,
Uh-huh.
having taught so many years, I just want to take this opportunity to thank you so much for your positive words. Every time we come to your class, I really, really, really get encouraged by these a minute or two nugget that you keep giving us, encouragement and how you understand our situation. It really, really cheers us on end. I would like to thank you so much for doing that and for making that so we can do this masters and complete successfully, even though we have a lot of challenges. So just going out of my way to thank you so much for doing that. Thank you.
All right. Thanks so much, Isaac. That's a positive encouragement for me as well. That even though I don't realize it, that I'm encouraging you, somehow you have noticed that my comments are sources of encouragement to you. I believe it will be to others as well. I don't know whether I said it here when we started this class some few weeks or months ago, when I said I know the challenges you are going through. And at this stage of your life, definitely you'll be going through a lot of challenges. Some of you might have married, some of you have kids, some of you are working, and all sorts of things. So there will be a lot of challenges you will be going through. So I said it on this platform, or if not even on this platform, I said it somewhere on one of the platforms, that I'm not here to add up to anybody's frustration. because people are already frustrated and they are going through challenges. Then the lecturer will come to class and come and frustrate people even more. Meanwhile, we are here to facilitate your learning experience. If I'm employed to facilitate your learning experience and I come and frustrate you all the more and the learning experience is distorted, then what do I achieve? I'm here to contribute to knowledge, and therefore I'll only stick to that one, irrespective of what other things that are happening. So my role or my conviction is to, as it were, encourage students to achieve their aim, which is very, very, very important. So thank you, Isaac, for recognizing the fact that somehow I've been encouraging you. Okay, that being said, we will move on to look at a few things. Isaac, next time when we meet physically, you should come and greet me so that I can remember your face.
Yes, Prof, I'll do so.
Yes. Okay. Any other? Okay, Prince.
Prof, good evening.
Good evening.
Please, we postpone our other meeting to next week.
Which
The one
meeting?
regarding the cybersecurity group.
The students. Yesterday was not a convenient time. You know, yeah, this political arena, I could do it, but I know people may not be in the proper frame of mind and all that, so it will maybe be a waste of time. That's why I call it off.
Definitely.
Yeah.
Okay, sir. And
So,
please, who is having the Google link to the recordings? If you know.
these recordings that we are taking, these recordings that we are doing here.
Yeah, the previous ones.
My TA, Prince.
Yeah.
You know my TA. He's part of this class.
I've forgotten the name.
He's Prince. He's part of this. He is doing the MPhil, so he's supposed to be here. He even creates the links and all that for us and share with us. So if you contact him, he will make the links available to the recording.
The link available.
Yes.
Okay. All right. Thank you, sir.
Okay. All right then. Okay. You even notice that even at this hour, only 15 to 14 students are here. I think some are still trying to come out from the joy or the shock that they had during the election results. So they are not here. Those who are not here, call them to join the class. Let's move on with our lives. Okay. Now,
Prof, is your candidate won?
Pardon?
Please, is your candidate won last time?
My candidate?
Yes.
No, I don't at this point want to talk about politics, but I just want us to have a class. You know the feeling if somebody is having or is too happy or somebody is too sad. We don't need to be talking about these things because maybe your joy will hurt somebody or your sadness may also hurt somebody you don't know.
Okay.
That's all. So
let's
move. You understand very well, is that not it? Mm-hmm.
Yeah.
We are all the same people, whether you lose or not, we are all the same people.
We are all the same people, yeah.
You understand? You know your candidate won.
You know, eh?
Yeah, we know.
Say you guess. Okay. All right, so let's move on and then see how far we can go today. You probably will be seeing what I'm sharing with you. Is it visible from your end? Parallel databases and distributed databases. Can you view it, the slide from your end? Can you?
Yes, please.
Yes, it's okay.
So now, this is what we started last week. We went through several interesting architectures. We saw the goals of parallel databases. And we said in a computing environment, things that really matter are divided into 5: processor, memory, storage, users, and then the network. We discussed various parallel database architectures. We mentioned shared memory, shared disk, shared nothing, and as well as a hybrid architecture. We moved on to talk about partitioning strategies, where we did mention horizontal partitioning, vertical partitioning, round robin, hash partitioning, and then range partitioning. After that, we quickly talk about parallelism techniques, where we saw interquery and intra-query, which we actually discussed this diagram to differentiate between inter and intra-query parallelism. So this, I believe, was where we ended the other day. Today we would first go to look at the distributed databases, but then there were some few challenges on the design of parallel systems. Some issues were raised on it over here on the design, which still research is going on to resolve some of the challenges. For instance, parallel loading of data from external sources is needed in order to handle large volumes of incoming data. So how do we load data in parallel from various sources? Then issues about resilience to failure of some of the processes or disks may also create problems, or might be something that we should develop so that we
Hello,
have
Prof.
robust system. Yes. You
Prof, please, there are
can you?
some people at the waiting room.
Why do they create this thing and put people in the waiting room? Prince, are you there?
I'm not sure there is a waiting room.
There shouldn't be a waiting room. Or still are people are in the waiting room. I am not the host who created, but I don't see people in the. What do I see people in the waiting room? Let me call Prince. Because there shouldn't be any waiting room in this matter. Okay, we can continue. Is going to sort out that problem of people in the waiting room. He himself drop out, but he is reconnecting. Okay, so issues having to do with failures of some processes or disk is a challenge.
Yeah.
Then there are also challenges with indexing of databases, and then query optimization, and then so forth. How joint operations can be used, how data should be accessed from various partitioning, and then also various schemas of databases, how concurrency should be handled in a distributed environment, or some of the design issues that are addressed or have been addressed. Okay, having brushed through that, we would go straight now to distributed database management systems. Distributed database management systems. When you observe this diagram very well, you will see certain kind of, so to speak, various, so to speak, locations. So we see location 1, location 2, location 3. Each location has its own memory and processor in a database, but they are connected through communication channel. They are communicated through a communication channel, as you can see over here. So observing this diagram closely, we can try to explain what distributed database actually means. So we come up here, we say distributed database is a system in which storage devices are not connected to a common processing unit. So you will see that the storage devices, in this case, they are the databases, so to speak. The databases are residing on the storage devices, the database. These databases are not connected to a common processing unit, but they are each connected to its own processing unit. So this location 1 connected to, with a processor connected to the storage device with the database, and then so forth. So for that reason, the databases spread across various locations can communicate among themselves through the communication channel, but more so, they will need some kind of middleware that will enable them, or that will enable one location or processes at one location to access databases at the other location. So the databases that we see here are controlled by distributed database management systems. You will recall when we started learning these database systems, the first day we talked about, or we saw a diagram on database management systems. So we saw the database, we saw users. In between the database and the users, we had database management systems. That's what we've been talking about for all this while. That in there we have queries, data definition, data manipulation, data control, transaction control, all those queries are embedded into database management system. When you observe here carefully, it's the same kind of architecture where we have databases residing at various locations, but in between them, before they can communicate and share their data among various processes across the network, there must be that middleware. And the middleware is the distributed, this time around is distributed database management systems. We've added the distributor to it that manage the databases across various locations. So we normally say that the databases are spread over the interconnected network. It is normally described as a loosely coupled system. The architecture that is normally used in this environment, the architecture that we saw earlier, like what we are seeing over here, you say that is shared nothing architecture. Shared nothing means each processing unit has its own memory processor and then the disk. So that is the architecture that is generally used for the distributed database systems. Of course, Oracle implemented shared disk architecture in the distributed database management system that we saw there other day. Okay. So having described this diagram, let's move on to look at other issues about it. But bear the diagram in mind because we will still be visiting it as we go along. What are the goals of distributed database systems? The goals are not different from what we saw from parallel databases. Of course, to improve reliability, that even if one system fails or stop working, the other systems should complete the task. That's one main advantage. Then also availability, data availability. Okay. All right, then the other one is performance. Performance. So these are the main goals of a distributed database. Now, the next thing to look at is the types of distributed databases. Please just give me a minute. Just all right, so we can continue. Yes.
I can't hear you, or I don't know if I'm the only one.
No, I said you should excuse me for a moment. So maybe you didn't hear when I said you should give me 1 minute. So I've not been talking for the past minute. But can you hear me now? Are you hearing me
I
now?
can hear you. I can hear you now. Sorry, I didn't. I can hear you
I
now.
step
Thank
up.
you.
I step up a little bit.
Okay.
Okay. Can you also see the material I'm sharing with you?
Right now, no.
Oh, why not? Are other students seeing the material I'm sharing with you?
Okay.
Yes,
Let's
Prof.
continue.
Okay, then the problem is coming from its location.
It has
Okay,
come now. It has come now.
okay, so let's continue. We just talk about the goals of distributed database systems. We want to come to types of distributed databases. There are generally two types of distributed databases. Once the databases are distributed, you have at one processing unit or a location, you have a database. You have another database allocation 2, another database allocation 3. And we said these databases can communicate among themselves through distributed database management systems, which may be located at one or more of the locations over here. So at location 1, we could have the distributed database management systems, location 2 and 3, and they can communicate among themselves. Having said so, the first type of distributed databases is the homogeneous distributed database systems. Of course, once we hear homogeneous, the meaning of a word is in the word itself. So, homogeneous distributed database system is a network of 2 or more databases with the same type of database management software. Okay. This database management software, the same type, could be stored on one or more of the locations or machines. In that case, it is easier because they are the same database software. So access to data and modification and so on can even happen simultaneously across the databases because the databases are the same. Databases are easier to handle. So as you can see from this diagram, when you observe the diagram very well, you will see that there are 3 locations or departments, Department 1, 2, and 3. They are all running Oracle. So we have Oracle at Department 1, Department 2, Oracle, Department 3, Oracle. So in this case, we don't have so much challenges because the databases are the same. But there are situations where we have different databases. And when that occurs, we say the distributed database system is heterogeneous. So with heterogeneous database system, we have 2 or more databases with different types of database software spread across various locations on different machines. In that case, the the communication among them will need to use some generic kind of API or middleware in order to create the interaction among the various databases. So if you observe this diagram, you will see once we have SQL Server here, you have Oracle on another, you have Access you may have Infomix, you may have DB2, and then so forth on various locations. In that case, you can use APIs, middleware, those different kind of this to be able to allow one database management system to communicate with the other database management systems. So we have something like ODBC and JDBC that can help to bridge a middleware that can help to bridge different databases such that they can communicate among themselves, because the databases are heterogeneous. Let me just find out what is the full meaning of ODBC. Anybody who knows it? ODBC means what? It's an acronym. Nobody knows what ODBC is. Okay, now JDBC. If you don't know ODBC, maybe you know JDBC. Anybody who wants to attempt? Okay, I'll tell you the ODBC. ODBC is Open Database Connectivity. Open Database Connectivity. Now that I've mentioned one, the second one, who can guess? Anybody's guess? The JDBC. Oh, it doesn't look like students are in this class.
Maybe it can be joint database.
It's joint for
Joint database connectivity.
what?
Joint database connectivity. Oh.
That's you guess, is that not it?
Yes, I guess, because this is the first one you're open.
Okay. Now that's good. Yeah, that's good. The
Java database
any
connectivity.
other person is what?
Java database connectivity.
Okay, it's Java database connectivity. It's Java. Okay. In our technology or IT environment, we always provide answers all the time. There is nothing like I don't know. So in our environment as a computer science or technologist, and you go somewhere and they ask you, can you build something IT something to us? We don't say that I don't know, because we know. And we know our work, that we know the principles very well, and therefore we know the application. Those of you who are hands-on will also know. Some of us, me, I'm a hands-on person. I like even the hands-on more than theoretical content. So we don't say I don't know. So when something question is asked, Erasmus made a good attempt. That this one, the way I look at it, since it is J over there, it's likely going to be joint something or database something. I'll tell you an interesting story. I was invited for an interview. So at the interview, it was a merchant bank at that time, several years ago. That was 25. So about 21 years down the lane. That time I was leaving Bank of Ghana. I want to come to academia. Then I saw an advert because I didn't like the bank work at all. It looks as I was being pinned down at one place, and always you don't have freedom, it's limited, and so I wanted to leave the bank. But I saw an advert and I applied. I didn't know why I even applied again to merchant bank. I didn't know at the time that it was a merchant bank. They just say a leading bank or something. So I went and they asked me a question. some question that they asked. I didn't know the answer. It was a practical kind of question. So somehow I provided some answer. And I said it with confidence. Then the IT boss over there raised his head and he squeezed the face and he raised the head. Then he nodded his head. Hey, gentlemen, this one you are educating me. He thought that what I was saying is right. So I was teaching him something new. So he was, oh, this one, yeah, now okay. So he thought I was educating him. Meanwhile, the answer I gave, I wasn't even sure myself, but he took it that I was educating him to learn something new. So our IT terrain, if you go somewhere, somebody brings a project or something, at the moment you wouldn't know. Our environment is such that we don't know that much until we pick the project and we investigate and see or do requirement analysis before we actually know what to do. So when you are asked a question, you to guess something. Guess, maybe that's the answer. A similar thing happened when I was presenting my master's thesis during the thesis defense. I told you before, I did my master's in China several years ago. That time when we went there, and then we were doing all this. Those days, we weren't too many masters, people doing masters in their numbers. No, it's not like that today. There were 6 professors on the panel. Then some of the professors, their main area was not into databases. I did something on databases. Then they asked me some questions. One of the questions they asked, I did some model. So I came back to the model to explain it first before the implementation. Then I explained the model to them. They asked some question I wasn't sure, but I answered the question confidently. The whole room was packed with foreign students and all that, and then some other Chinese friends and the professor. So when I answered the question, I can see from the face of my supervisor that he felt I didn't answer the question correctly because he was subject expert in the area. But the other 5 that were sitting there, I saw them nodding their heads, and then they were beginning. I convinced them. I answered the question because they didn't see any kind of expression of doubt in my answer. And all of them were grading you differently. So at the end of the day, they graded because they thought that the answer was correct. You see, 5 thought that. So if you are asked a question, you to provide some answer. For all you know, it is close to the answer. But don't keep quiet and say, I don't know. Our terrain, we don't say, I don't know. There were projects that I have executed that at the beginning I didn't seem to know. But once you are going to it and do requirement analysis and all that, you say that, this is nothing. But initially, you don't say, I don't know. Okay, that's by the way. Erasmus, thank you for providing an answer that is joint database management system. So it's Java. That's by the way.
Okay.
I just want to tell a little bit of story before we go ahead.
Maybe this one will
Okay.
help me to remember it very well.
Yes, you won't forget it again.
Yes, I'll forget it.
Java database connectivity and ODBC. These are some of the things we work with a lot in the past that provided us with a middleware to extract data from one database to the other database and so forth. Okay, so that is heterogeneous distributed database system. There were some issues with of course, when you have databases residing at various locations, even when they are at one location, you remember that we had a problem with concurrency, the number of users accessing the same data object at the same time. And now you can imagine them now split across various databases. So the issue of concurrency still crops up here. So the problems are failure at some locations. So even if we implement the concurrency protocols and so forth, they should be able to handle if one location fails, what happens? Systems to undo or recover from the failure should be implemented. What about failure at the communication location? The communication line itself can also fail. So what happens? If, for instance, various processes are executing queries from various locations, and at the end of the day, they put their results together to provide one outcome, and then one communication line fails, or one location cannot be accessed, then trouble. So mechanisms are built or should be built into it. Next semester, we'll be looking at a full course or program, so a full course on distributed systems, and then these things will be delved into detail. So, but just bear in mind that there will be a lot of challenges when accessing data from various locations in terms of concurrency and these rollback mechanisms and so on. Okay, even commit deadlocks, rollbacks, and so on will become an issue. But when we studied this last few weeks, we knew of the fact that locked-based protocols should be able to handle such shared lock, exclusive locks are implemented to take care of the challenges that we raised, even though some challenges still exist. That's why research is still ongoing to address issues. Okay. Having said so, I think we can jump this. We talk about middleware. We talk about this architecture. Distributed systems normally dwell much more on client-server environment, but this topic will be dealt with when we come to next semester on distributed systems. Okay. Now, I'll pause here for a moment. If you have any question to ask me, you can do so before we continue. Okay. Once you don't have any question, let's move on to the next section. We are now coming to talk about replication. You see, when you have databases spread across various locations, to recall last week or so, we mentioned that data can be partitioned. We can partition data horizontally or vertically. Assuming that we partition data vertically, and a segment of some of the columns are residing on one server or in one database. The segment is also on another database, or even when you partition horizontally, some of the records are at one location. Segments are on the other location. Then you begin to figure out the complication, assuming we want to issue a query to search for a particular record. How do we even know which of the partitions that record resides? So in that case, the query will need to now find a way of accessing data across various locations in order to find that record. But we talk a lot about, even when we split the data, the better. But when you split the data, then we also have to be thinking about the queries. The queries to fetch data across various data bases. So let's come to look at replication. So what is it? The process in which data is copied actually at multiple locations, different computers on servers to improve our data availability. So now we make copies of data to various servers, or segments of data to various servers or locations. The purpose is to improve data availability. The goals are here. What are the goals? One, data replication is done with the aim of course, increase availability, speed of query, evaluation. These are the main goals, where we have types of data replication. There are two types of data replication. How do we make copies of data across various or multiple locations? We can use the process we refer to as synchronous replication. So for synchronous, the replica will be modified immediately after some changes are made in the relation table. So if we have a replica of a database on another database, the replica on another database, the moment the update is done on one of the databases, immediately, real time, the update affects the replica, most probably residing on a different database at various locations, of course, through the communication channel. So that is the synchronous replication. Now, the other one is asynchronous. The asynchronous is a replica will be modified after a certain time duration, where we can issue a commit to now move the data from one replica to the other database residing at a different location. So these are the two types of data replication that we have discussed. Which of this do you think is better? Which one is better? Synchronous, real time, that where if the data is at, let's say, 10 locations, once we make updates to one of the databases, immediately the data should be updated at all the other locations. the asynchronous, when the data has changed or updated at one location, we take a while and we issue some commit to commit them into all the other locations. Which one do you think is better and why? Yes, let me, Isaac.
Prof, I would say it depends on your aim of whatever you are of your project. And
Okay.
also it also depends on your facilities. So if communication is a challenge, or communication is between your databases, your distributed databases is a challenge, or probably communication would delay the processing which you would need, then it means you might tilt towards asynchronous, so that the replication would not take so much of your communication channels. But if communication, you have a system going and the communication is good, then in that case you might favor the synchronous, especially if your distribution is not that many. So it depends on the situation, or depends on the project with which you are using the distributed database to solve. That is my answer.
Okay, thank you very much. Now let's come to Erasmus. Erasmus, you raise your hand.
Yes, I will say that the synchronous one is the more advantage because
Which
you
one?
don't need
Synchronous or asynchronous?
synchronous.
Okay, all right.
Synchronous because everything would be automatic. But I will say that asynchronous too can help to control maybe the mistake or the error that can be provided or can be on the channel, so that at least it can be yes, it can be corrected before it should be abated.
Okay.
So, but it depends on what exactly, which kind of security we are putting in place for the data. So
Okay.
this one will be in the at the level of the administrator to take all the decisions.
Okay, all right.
Thank you.
Thank you very much. Now, Evans.
Okay, Prof. I also think both, it depends on your use case, what you want to use it for. Both can serve as relevant depending on what you want to use it for. So let's say you want to let's say for the synchronous like this, you have a distributed database where people are accessing data in real time, like they're accessing data always. It would be very prudent to use the synchronous, because then all of them have like data, the same instances of the data that is in the system. But then with asynchronous like this, I think it can also come in handy when you are storing data, and also you are just storing data. Yeah, you have a system for, let's say, storing very critical data that you wouldn't want, let's say, mistakes in. Yeah, so you would need some level of verification for people to um, access it. Then that one will be relevant in that use case.
Okay, that's fine. We'll take the last comment and then we'll draw a curtain to that. Al Hassan.
Good evening, Prof. I think
Good
as
evening.
yes, as they have said, actually it depends on the use case, what you are going to use this thing for. So basically, if you are using it for sensitive transactions that need to be replicated instantly, actually you have to use the synchronous. But transactions that do not need to be immediately available to other units, I think you can use the asynchronous.
Okay. All right. I think you've all provided the answer. Al Hassan, let me just ask you, in our academic environment where we lecturers enter grades, do you recommend that we use synchronous or asynchronous? Where we student lecturers we capture grades into your ERP. Then we have backup sites at other places that when we capture the data, we want to store them across about some 4 or 5 locations. Do you recommend synchronous or asynchronous, and why?
I think I would recommend asynchronous because I think for me,
Asynchronous.
asynchronous. I think
Okay.
mostly me, I only recommend the synchronous for financial transactions that need to be available instantly across the various database centers.
Okay. I think
That's
you've convinced me. I will also like academic environment. I will also go for, like, for instance, if it is a grade, then the asynchronous should be better because there is no agency in a real time kind of issue. Now, financial environment, fine. The synchronous is fine. But let's say the school payments that you made on electronic platforms. How long does it take for you to see it reflect? I mean, when you pay fees at with using the electronic platforms and so forth at the University of Ghana, how long does it take? Is it synchronous or asynchronous? Erasmus.
it takes time.
It
Takes
takes
time
some
before
time to reflect.
Asynchronous.
Is async. Why do you think that it should take time for it to reflect? Because if it's done at the bank or whatever, why wouldn't it be synchronous and hit your account instantly?
Prof, the electronic one is synchronous. So
Pardon?
the electronic one is synchronous. If you are paying it electronically, it's synchronous. Immediately you pay, you receive a receipt, and then it will
But
reflect in your student portal that you have paid based on the platform.
based on the platform, okay. All right. So
Yes.
these are the, as so to speak, the 2 ways based on what you want to achieve. I developed a system for a company, and then the the network was not good at all at the place where they were operating from. So they said that we should make it synchronous. So anytime the thing hits the banks, it should reflect immediately on their accounting software internally. So their network was not good. So I told them that this one, your network is not good. Sometimes your network is down and all sort of things, so it's not going to work. They said, "Oh, we want it that way." I told them, but eventually it never worked. So what they now do is they wait till evening. So at the evening, at end of day, then they can use the synchronization software, the middleware, to pull all the data into their system. So they now do it at once because the network is not going to be holding individual records or transactions happening. So you see that based on situations and environment and so on, one may choose synchronous or asynchronous. Okay, having said so, let's move on to look at some other issues regarding replication. We also have the schemes or replication schemes. There are 3 of them. One is full replication. full replication. In that case, the database is available to almost every location or user on the communication network. So you will see in this case, the full database is available, the original. The original is the copy of the original is what we again see in the replica. So the replica and then the original are the same, the content the same. That's full replication. But sometimes full replication may not be needed sometimes. But let us see the advantages of the full replication before we move to other schemes. The advantage is high availability of data. The database is completely available in every location. Of course, faster execution of queries. We don't need queries to be accessing various disks at various locations before they run a query and find results, because the database is fully located also at the various locations, and the data is available. Sometimes you will see you want to make some copy of the data, and then you use the site that is close to you with a better network. You can download or work with that database rather than the one that is also on the network, maybe with poor network. Because you have full data, the data on each location, you don't have a problem because you can fetch the data that is easily available to you. Then the other one is concurrency control is difficult to achieve in full replication. Then update operation is slow because you need to be copying data from one end to the other end. The replication could be slow. The second schema, we call it no replication. That is, no replication means each fragment is stored exactly at one location. So in this case, when we split tables, one fragment stays on one disk, another fragment on another disk. Even though there is replication, each of the locations are holding segments of the data. Okay. Now the advantages are here: easy recovery and poor availability of data, slow down, so forth. We also have partial replication. Partial replication is very common because we can't be always, based on the application in question, always making full replication of the data to other locations. Sometimes not too many things have changed in the original. So why do we need to copy all again and then be sending to various locations? So we can use partial replication. I use partial replication a lot for the systems that I have. At the end of the day, the tables that frequently change. Some of the tables are almost static. They may just be setup tables. They hardly change. But some of them change rapidly. So at the end of the day, we may copy just those ones that changes have occurred in. Then maybe occasionally, before we copy or do full replication, we normally will do partial replication where some fragments are replicated. So that diagram also explains that it has its own advantages and disadvantages as well. Okay, I will pause here to take your questions, if any, before we continue. Evans, you've raised your hand.
Okay, it's an old hand. Let me drop it, please.
it's on hold, and then you should lower it. Okay, I'll Hassan.
Hello, Prof.
Uh-huh.
I want to find out regarding Microsoft SQL Server. They have what you call linked database, where you are able to link remote databases and work with them like the way you work with local database. Do you also consider that one as a distributed database system? So that's what I want to find out.
You can link to remote database and work with it. Is that not it?
Yes, you work with it like the way you work with local database. They call it link
But,
service.
yes, but do we have a? Does that database also communicate with other databases on other servers?
Yes, like all the other servers that have that particular functionality, they are also able to connect to it and then extract the data. Just work with it like the way. For example, if you
Yeah.
have
So
one,
if we have other databases also work seamlessly with it, then it's a distributed database.
okay,
If you have other databases that work with it, we have distributed it. Maybe there are some databases that you also at the local on the local server. You can combine data from this and the other, and then so forth. Then it's a distributed databases. Okay. Any other question or comment or suggestion or addition? Okay. Now, the next topic that we want to discuss is query processing and query optimization. But I do not want to discuss this topic today because I want to provide some fundamentals of query optimization before we link it to distributed databases, which is going to be a topic on these two main headings are topics on their own that will be treating as a chapter. So I would postpone the discussion on query optimization and query processing. When we discuss the concept, then we can link it to actually the discussion will be linked to databases as well as distributed databases. And this is the last thing that we have on the slide over here. Now, with all the discussions we are doing, as I told you, this is quite summarized. I normally do not want to use the summarized versions of this. You'll see me sometimes opening the textbook itself. So I would encourage you to look at the textbook that we are using. I'm sure you can see my slide from your end.
Yes,
We
Prof.
are, yes.
Yes,
So
Prof. You can see it.
what we have discussed on the slides over there are contained or are the summaries of what is here, particular chapter 22 and chapter 24. I have not yet talked about the mobile databases, but I talk about replication. So please, in addition to the material I used, a deeper understanding will come from chapter 22 and chapter 24, what we have discussed over there. Now, you remember we did chapter 20 some time ago. This is the query processing and query optimization are here, chapter 21. We'll be coming back to that in our subsequent lectures. Okay, so in the meantime, I would want to end this class here and leave chapter 22 and 24 with you to read thoroughly, because that's the summary we saw on the slide we discussed. When we meet next week, We'll be diving into this data warehousing, also very interesting concept. Data warehousing design, online analytical processing, and data mining. With 2 classes, we should be done with this. I also have very interesting material summarizing these chapters here. Then eventually we will come back to look at query processing and query optimization. Okay, having said all this, if you have any further question or comment or suggestion, you can let me know before we run off the class today. Okay, so on this note, we'll end it here today and see you next week. Bye-bye.
Thank you, Prof. Bye-bye.
Thank you. Thank you, Prof.
Bye. And Mr. Prince, please make the link available for us for the recording.